Hi, Algebra 2, here's the notes from Friday if you were out, or if you needed to review it. For our warm-up here, we're solving just the way we've done before. This one I've got the first term and the middle, or the last term, but not a middle term, so I'm going to solve by the square root method. When x squared is equal to 9, I'll take the square root of both sides. X is equal to plus or minus 3. If I were to graph x squared minus 9, that's taking my parent function and shifting it down 9 units. So instead of being centered at 0, 0, be centered down here at negative 9. And then I have a point here, and a point here, and here. And across my axis of symmetry, hopefully you remember some of this stuff from Algebra 1. It would be a problem that looks like this. And so if you notice, these solutions that we came up with here are also where our graph is equal to 0. All right, for the second one, I've already got the square by itself. So I'm going to take the square root of both sides, and I get x minus 4 is equal to plus or minus the square root of 0, which is 0, which is really just x minus 4 is equal to 0. Adding 4 to both sides, I get x is equal to 4. Looking at the graph of this one, now my transformation is happening inside the parentheses. It says to go to the left 4. Instead, I'm going to go to the right 4 and draw my parabola. And again, notice that my one solution, x equals 4, is where, well, if I had drawn this a little bit better, is where this parabola touches the x-axis and bounces back up. So when it touches it once and bounces back up, that's my one solution. When it crossed 2 times, I had 2 solutions. Let's look at this one. Let's graph this one first. This one is taking my x squared and moving it up 9. So I am centering not at 0, 0, but here at positive 9. Now where does this guy cross the x-axis? It doesn't, you see. So I shouldn't have a solution for this one. I'm going to move this 9 to the other side, and I get x squared is equal to the square root of negative 9. It's equal to negative 9. Then I take the square root of both sides, and I get x is equal to plus or minus the square root of negative 9. This isn't a real number, so we say no solution. However, it doesn't have a real solution. It has what's called imaginary solutions, and that's what we're going to explore today. So scrolling down here, it says, what part of the graphs do the solutions to the equations represent? Well, that's just, the solutions are where my parabola crosses the x-axis, where x is equal to, or y is equal to 0. And then an imaginary number, I is the square root of negative 9. That's what it means to be an imaginary number. It is a not real solution. Not a real number. It's not real, it's imaginary. All right, so if we look at example number 1, I'm going to move my 9 over. I get 1/4 times x squared is equal to negative 9. I'm going to get rid of this 1/4, so I'm going to multiply by 4. X squared is equal to negative 9 times 4 is negative 36. We're going to take the square root of both sides, and I get x is equal to the square root of negative 36. Well, negative 36 is negative 1 times 6 times 6. So that'd be 6 times the square root of negative 1. And we said negative 1 is I. Sorry, this is plus or minus the whole way through, Miss Harris. So this would be plus or minus 6i. So this is another graph that does not cross the x-axis. It's got 2 imaginary solutions, no real solutions. For example, number 2, first we're going to add 4. We're trying to get that x squared by itself. I get 5x squared is equal to negative 8 plus 4, which is negative 4. Dividing by 5, I get x squared is equal to negative 4/5. And now I want to get rid of the square, so I'm going to take the square root of both sides. X is equal to plus or minus the square root of negative 4 divided by the square root of 5. Square root of negative 4 will be plus or minus 2i over the square root of 5. Because the square root of 4 is 2, square root of negative 1 is I. But keep in mind, we can't leave that square root of 5 in the denominator. So I'm going to rationalize my denominator by multiplying by the square root of 5 over the square root of 5. This would give me plus or minus 2 square root of 5, 2 times the square root of 5, all over square root of 5 times square root of 5 is positive 5 times I. And those are my two imaginary solutions. Right, example number 3. First, I have got to distribute these guys. So I've got 5 times 2x squared would be 10x squared. 5 times negative 3 is negative 15. 4 times x squared is 4x squared. 4 times negative 10 is negative 40. And then we're going to get all the x squareds on one side, the left side. And we're going to move the 15 to the right side. 10 minus 4 would be 6x squared. Negative 40 plus 15 would be negative 25. Dividing both sides by 6, I finally have x squared by itself, which means now I can take the square root of both sides. So x would be plus or minus the square root of negative 25 divided by the square root of 6. Square root of negative 25 plus or minus would be 5i. Square root of 25 is 5. Square root of negative 1 is I. All over the square root of 6. But I don't want to leave square root of 6 in the denominator. So I can rationalize the denominator by multiplying by square root of 6. So that gives me plus or minus 5 square root of 6 over square root of 6 times square root of 6 is just positive 6. And then we always put I in the end. And hopefully that made more sense today when we did it in class on Monday. And that's all of your notes for today. If you have questions, please come to tutorials Tuesday and Thursdays, A and B lunch. Room 1026. Have a great night, guys.